Hi everyone, we are from Group 23, here to present our group assignment 1. First of all, I would like to introduce myself. Vetrivel Muttalagan, matrix number BB23161108. I'm here to present the first part of the group assignment 1, which give an order to construct appropriate graph charts to compare the relative frequency and cumulative relative frequency from each data set. As we can see, we have two tables over here for number of visits and number of purchases. Each table consists of four aspects, which mean from class, calculate in million, and frequency, relative frequency, and cumulative relative frequency. For the first table of number of visits, the lowest class is 0 to 10 million, while the highest is 50 to 60 million. The highest frequency is 13, which came from the 30 to 40 million class for number of visits, and number of purchases. The lowest class is 0 to 110 million, and the highest class is 230 to 240 million. The highest frequency is from 150 to 160 million class. As we can see, the relative frequency, the graph for the relative frequency, the 30 million to 40 million is the highest, while this 40 million to 50 million class is the second highest, and third highest is 20 million to 30 million, and the lowest is 50 to 60 million. As we can see, the graph of relative frequency of number of purchases shows that the class of 160 million to 170 million is the highest in the category of number of purchases.
Hello, I am calling my son Alfred with metric number BB22110509. We'll be presenting for part 2, which is to calculate and compare the measures of central location between the two metrics. As you can see from the table shown, we have two metrics which are the number of visits in million and the number of purchase orders also in million, with a total of 30 datas in each metric. Mean is a primary measure of central location, also known as the average of the dataset. The mean is calculated by adding up all the values in a dataset and then dividing the sum by the total number of values. For the number of visits, the mean is 37.71 million. On the other hand, the mean for the number of purchase orders is 166.82 million. The median, when data is arranged in ascending order, is the middle value if the number of observations is odd. In the case of an even number of observations like this, we have a total of 30 data points, which is the average of the two middle values, specifically the data point at the 15th position and the data point at the 16th position. For the number of visits, the data point in 15th position is 34.1 million. Meanwhile, the data point in 16th position is 34.9 million. Hence, by averaging these two middle values, the median is 34.5 million. As for the number of purchase orders, the data point in 15th position is 163.3 and 164.5 is in the 16th position. Therefore, the median that we will get is 163.9 million. The mode in a dataset is the value that occurs most frequently. A dataset can have no mode if all values occur with the same frequency. One mode, which is a unimodal, if one value occurs more frequently than others, or many mode, which is multimodal, if multiple values share the highest frequency. For the number of visits, the mode is 34.1 million, making it unimodal. This implies that 34.1 million visits occurred most frequently in the dataset. In the case of the number of purchase orders, there is no mode, which indicates that no particular value stands out as occurring more frequently than others in the dataset. In conclusion, as we compare these measures of central location, we gain a nuanced understanding of the central tendencies, distribution, and frequency patterns within our datasets.
Hello, my name is Mohammad Daniel Zulfadlan Shabin Ali and my matrix number is BB2211 0.0264. So we continue to the part 3. The question is calculate the percentiles and construct box plot for each metric. So first we go to the first metric, which is number of visit. We need to arrange the value from descending order to ascending order, like at the table given in the presentation. Next, after we do the ascending order for number of visit, we continue to put the value and find the value for each percentile, which is, as you can see at the table, we already have minimum value, first quartile, which is 25th percentile, median for the second quartile, third quartile, and the maximum value. So from the value that we calculate, we need to construct a box plot, like you can see at the presentation. That's a box plot for the first metric, which is number of visit. After we finish the first matrix, we continue to the second metric, which is number of purchase order. It's same with the first metric. We need to arrange the order from to ascending order. So we, like you can see at the table, it from the small value to the larger value. Continue to calculate the percentile and construct a box plot for a matrix, which is number of purchase order. So firstly, we need to find the value for the minimum value, the first quartile, second quartile, or we call it median, third quartile, and the maximum value. So for the minimum and maximum, we can get from the table that we arrange to ascending order before this. And for the first quartile, second quartile, and the third quartile, we need to use the formula to get the answer, which is we at the below the table and the box plot, we have a formula. We already use formula to get the value. And for the box plot, we need to find the difference between each quartile. So we get the distance between minimum to first quartile to second quartile, to median to the third quartile, and until to the maximum value. That's all for the part 3. Thank you.
Hello, my name is Alvin Ajirin with matrix number of BB22110477. We'll be presenting part 4 of calculate and compare measures of dispersion in each dataset. The first step of dispersion measurements is to know the range. It is the simplest measure capturing the spread between the maximum and minimum values. The formula for range is by subtracting the maximum value and minimum value to know the number of visits. The max value of 54.2 subtracted by mean value of 23.0, which equivalent to 31.2. Meanwhile, for number of purchases order, the max value of 231.9 subtracted by mean value of 11615, which equivalent to 115.4. The second step is mean absolute deviation. It is the average distance between each data point and the dataset's mean. The formula is by firstly calculate the mean, then finding the absolute deviations, adding those deviations together, and lastly divide the sum by the number of data points. By referring the table given, these are the mean absolute deviation for each of the e-commerce website. The total MAD value for the number of visits, as we can see, is negative 8.6, while the number of purchase orders is negative 5.5. The third step is variance and standard deviation. It is to measure how far each value is from the mean and providing a more detailed picture of variability. Variance is derived by taking the mean of the data points, subtracting the mean from each data points individually, squaring each of these results, and then taking another means of these squares. Standard deviation is the square root of the variance. Thus, based on the table given, we can now identify that the variance value for the number of visits is 4.02, while the standard deviation is 10.98. Meanwhile, the variance value for the number of purchase orders is 51.70, while standard deviation is 39.98. The last step is coefficient of variation. It means to expresses the standard deviation as a percentage of the mean, enabling dispersion comparison. The formula is by dividing the standard deviation by mean, then multiplying it by 100. For the number of visits, 10.98 divided by 38 equivalent to 0.29. For the number of purchase orders, 29.38 divided by 167 equivalent to 0.24.
Assalamualaikum and hello, my name is Muhammad Izzuddin bin Abdul Dahlan, matrix number BB22110799. Today I will presenting part 5, which is calculate and interpret measure of association between two metrics. Based on the data table, we can identify two variables, which is x and number of visit and y purchase order. First, we need to calculate covariance. Sxy equal to the sum of x minus x bar multiply y minus y bar divided by n, which is sample size minus 1. From part 2, we know that our mean for x is 37.71 and y is 166.8, and the sum of x and y is 5130.39. Using the formula given, we get our covariance value is 176.91. Once we got the covariance value, we can use it to calculate the correlation. The sample correlation RxY formula given as RxY equal to sample covariance divided by standard deviation x multiplied by standard deviation y. Using the formula given, our correlation Rxy is 0.66, and we can conclude that variable x and y have a positive relationship, and the strength of linear relationship between variable x and y is moderate. Thank you, that's all.